I'm doing wrong here. Oh, here we are. You know, I found the StreamYard controls to be totally confusing. I can't figure out what they're totally and completely counterintuitive in my mind. And Zoom is much.
Right. Point taken. But the recording of yesterday, I think you found this out. There was one mistake. When you brought yourself down, you got rid of your audio. So
Yeah,
the way to maximize, there is a way to maximize the screen, getting rid of your photograph but keeping yourself up. You don't bring yourself down. You go to a little pull-down menu at the very top, some dots, and you just say maximize screen.
Yeah, well, that's a mistake.
Right, we were silent for 15 minutes or something.
Yeah, well, I just hate, and then that's just not helped by the fact that when people were talking, the computer got completely bogged down, and then it would start spinning wheels. The screen would go, and everything would turn into spinning wheels. It's just not happy for me.
I mean, I take your point that this is arising in StreamYard more than anything else, but it's possibly because StreamYard just requires a greater bandwidth. You know, it's a problem with the line you have, I suppose.
Well, I thought that, but then I've upgraded. I'm at a pretty high rate,
Right.
300 megabits or something like that. I don't understand why that wouldn't be sufficient. Works fine with Zoom.
Yeah, it should work fine with Zoom. You have a fiber connection, I take it.
Yes.
You have fiber. Yes.
Yes. I think it has to do with the way Zoom and my computer talk to each other. The more people that are involved in the conversation, I think it tries to make everybody come in at the same time, even though they're speaking from different places with a different delay. And I think it tries to make it so that all the different delays get synchronized together, and I don't think it does a very good job.
See, I wonder what the difference is, because in my case, I don't seem to have those problems. I don't have any faster speed than you do or better system, but I don't seem to have the problems you have, Harry.
Yeah, well, could be my computer. I don't know.
Yeah, maybe it's the computer.
I have noticed that it doesn't like it when you have a background. If you're running a background application, that bogs down StreamYard. Doesn't seem to bother Zoom, but it bogs down StreamYard. So, for instance, if you're running, you have one of these programs that comes on and starts looking for viruses in your computer. When that happens, my computer just doesn't like that. So I have to make sure the virus programs are turned off, so it's not scanning for viruses while I'm running StreamYard.
Okay, that's probably what it is.
All right, well, good morning. Did anybody take a look at, see, I did it again. All right, here we go. Anybody take a look at Eddington's book?
Well, I just saw that just a little while ago, but I actually have the book, and I read it about 30 years ago. I have it on my shelves here, little paperback.
Yes, that's the Pelican.
Yes.
Edition. I think that's 1940. Okay, is this up here now? Can you see this? See my slide? Is it working now?
No.
No. Not yet.
There's no slide there?
not now. No, not yet.
All right. About now? Is it working
Something.
now?
Ah, yes, something's coming up.
It says you've started screen sharing.
Yeah,
You don't
it'll
see
take a
it
moment.
See it now?
Yes.
Okay.
And it's so much clearer than on the StreamYard version. You know, Harry, if you could X out the properties on the right, you know, that's just taking up screen space.
Yeah,
Well, close the properties on the right,
that didn't work.
in the right panel.
The little X, top right-hand corner, no?
Yeah.
Well, that didn't help. Now it's gone.
I don't. Well, I still see your slide and the properties. So.
Or even pull it across. If you could put your cursor on the vertical line and just pull it across, it may work.
Yeah, the problem is that I don't have it on my screen now. I don't know where it went. That wasn't helpful because I don't see the slide now. Where the slide went away.
I see it. Yeah. You probably have to reload it then.
You see it now?
Yes?
We see your slide, expansion of the universe.
Yeah, but I don't see it. That's you still
Maybe
see it?
you need to minimize your Zoom screen and look at your regular screen.
Well, that's what I did. Do you see it?
I see it.
I don't see it when I switch to Zoom. I don't see it. I don't know why I don't see it.
At the top it says normal.
Oh, there it goes. Do you see it now?
Yes.
Nothing's changing. We're seeing it perfectly. You can have normal outline, notes, handout, slide sorter.
All right. So this has bothered me for a long time. What is the expansion of the universe? What does it mean? Does it mean that galaxies are all moving apart? Milne, I think I mentioned this about Milne's theory. He had this suggestion that if you have like a normal distribution of velocities, the galaxies that are moving, the particles that are moving faster will, after a period of time, be further away than the ones that are initially moving slower. Okay, and so that was kind of his idea about what. There wasn't any expansion of the universe. It was just a result of a distribution of velocities of galaxies, which meant that the ones that were initially moving fastest would eventually be seen to be further away, and that was his explanation of the Hubble law. Or does it mean that the galaxies move apart as the space of the universe expands? Okay. That isn't really exactly clear to me what that could mean. Maybe the space is expanding. How does space expand?
I've actually heard that it's space-time that expands, which time and space aren't physical phenomena. You know, I mean, they supposedly bring along all the mass and energy of the universe with it. However, though, I mean, space is just emptiness. Time couldn't possibly expand. That's just an altogether different concept, completely. You know.
Well, yeah. The reason I'm bringing this up is I'm kind of interested in other people's views on this. To me, you know, you read these books and they tell you, you know, oh, we know, but it's not clear to me that that what a textbook says that really translates into people having. What does that translate to into what people think it means? I'm not sure. I have the problem I have is that you're taking relativity, and relativity says there's no absolute space or time, and there's nothing absolute. There's space is all relative, time is all relative, and then suddenly that gets translated into via the general relativity, that gets translated into there's an absolute time of the universe and there's an absolute space, and the absolute space is expanding with absolute time. And so how did that happen when you started out with a theory that was based on there's no absolute? Do you understand what I'm saying?
Oh, a contradiction.
So you see it as a contradiction. Interesting.
I think it's a Doppler. I think it's a Doppler explanation of the redshift is to be believed, and that there is an expansion. I mean, I've said this before. That I think it's local. You know, that there was a gigantic explosion that had occurred within a universe that already existed.
Okay, well, that's an interesting. That's.
I mean, it's possible there's alternate explanations for the redshift, though, which I've heard different accounts.
Right, and that's
But maybe the universe is static, or that it doesn't expand. You know?
Yeah, these are all supposedly ideas that have been rejected, and they've basically come to some basic conclusions. And then the third option, this is the one that they picked. Does it mean that the behavior of space as a function of time is a mathematical dilation, basically a stretching of space? Okay, that's kind of what seems to me to be what they're claiming is the actual truth of cosmology. And then down at the bottom, if you believe the stretching of space idea, does that mean that things like the Planck length are also stretched as the space dilates, gets stretched out? And I don't know whether that's whether they say that or not. To me, I have a question about that. My assumption is that the Planck length, maybe I'm misunderstanding what Planck length is, if somebody could clarify it. I thought that was a fundamental length of quantum physics.
Yeah, I mean, I never quite understood the Planck length, the Planck scale, and I looked it up the other day, and as it turns out, there isn't any evidence for it. I don't know how it was arrived at, but people use the term all the time.
Well, there's another question then, huh?
Well, but I don't know if they say that the size of the atom, you know, say the electron radius or whatever, changes. Does that expand as well, or is that constant?
I think the answer is it doesn't change, that it's fixed in size. And to me, this is I've talked about this before, and Fred Hoyle in his book talks about this, and he sort of implies that the accepted notion is that the size of atoms don't change, even though space is expanding. And so you ask yourself, if space is expanding or stretching, why doesn't that stretch out or cause the size of atoms to change? But that apparently seems to be an assumption. So I don't know that I've ever seen a clear answer to this issue.
Well, I would just guess that if there is some sort of expansion, that all physical phenomena, whatever object that it is, however small or large, would stay the same size, but that they're just rushing away from each other, maybe.
Well, that goes back to the original idea. Uh, you know, the one at the top doesn't mean that galaxies are all moving apart. Okay, so the galaxies are all moving apart. That doesn't say anything about space changing, right?
Yeah, I think that was the initial position, and it developed into the second one. The initial position was rational, whether it's right or not, that things are flying apart, but space is not expanding.
Right, and
If all of this is based upon the redshift, a point that I've raised previously is Compton scattering would tend to redshift photons arriving at our detectors, and it doesn't mean any Doppler effect at all. It's a Compton scattering phenomenon. And so
that's a tired light idea.
Excuse me?
That's basically tired light concept. What you just described.
I guess it could be in that category. I wouldn't object to that.
That's my understanding of how they interpret the word tired light. Is this idea that we're talking about Compton scattering, which is scattering off of.
I'd like to frame the question in this way: is there any solid evidence at all for expansion that doesn't have an alternative explanation in commonly known effects, such as tired light or Compton scattering, which wouldn't necessarily mean law? Well, yes, Compton scattering, light would lose energy, and that would be transferred to particles that it interacted with along the way. So, is there any explanation for or evidence for expansion that it doesn't have an alternative explanation?
I think not.
No, there's a paper by Hubble and Sandage, actually, which just states the observations and said these two explanations are alternatives, equally possible. One is that the galaxies are flying apart, and the other is that there's a tired light, and they give equal weight to both of them. I think that paper is maybe 1940s or something like that.
Right.
The reference if necessary.
So this discussion, in some respects, might be like trying to compare the worldview of Marvel Comics with Walt Disney Productions, and which one is more correct. In other words, it's sort of like all speculation.
Correct.
I think we could rule out certain things, though.
Well,
for even reason, an observation.
the reason I brought this up is because I think, and now I have the Eddington's book establishes expanding universe paradigm. I think really this book sort of puts this in a whole idea of what expanding universe means and why they've chosen a particular view of it. I think this book is the book that really basically sets that in concrete. Do you understand what I'm saying? No comment on that. So this comes from his, I think the original book was based on lectures in 1932 and then published in 1933. And then Ian mentioned there's a paperback book that was published in 1940 by Penguin. And I guess that's probably the version that is easier to get if you want to basically get a copy of it. I don't know if there are any reprints, but he says in the ideal now tentatively held, I deal with the view now tentatively held that the whole material universe of stars and galaxies of stars is dispersing. It doesn't say expanding, dispersing. The galaxies scattered apart so as to occupy an ever-increasing volume. So that's kind of a different statement of than that the universe is expanding, but he's sort of tried to make it more clear in his definition. And this goes on. The hidden hand in my story is the cosmical constant. Okay, now this kind of threw me, but I think he means the cosmological constant.
I think I'm on it too. I read some of it. Yeah.
So he's taking the view that the expansion is due to the cosmological constant. It's kind of interesting. In the astronomical part of the book, I follow generally the theory of Lemaitre. There is a difference in our views of evolution, but from my point of view, this is a very minor divergence. So he's saying, in essence, for the most part, he agrees with Lemaitre, which I've talked about before. And you have to remember that this is 1930, basically at the beginning of the 1930s. And there really weren't, there was the Einstein had his idea of the static universe. So Einstein published the general theory of relativity initially in 1916. And then there was, he did a static universe model, and then Dissident came up with another model, and that was in 1917. And then Friedman, I think was around 1920, he published some solutions to the general theory of relativity equations. And but the Friedman's work was not really, they didn't really pay much attention to. As a matter of fact, most of the stuff was really obscure at the time. And then Coleman published a book, and I think that was early 1930s. And there are a few other sources. The amount of literature about this is really kind of thin. And this was, from what I can gather, a very esoteric, very esoteric kind of scientific endeavor, this cosmology endeavor, and the people didn't really talk to each other very much. And one of the main players, of course, was Eddington, and Einstein was another major player. I think Dissident probably was a well-known player at this time, and and I think Eddington was probably the most important one because of he's famous for establishing the quote proof of general theory of relativity. In 1919 they did the eclipse experiments and proof of the bending of light. So Eddington is a big important player, and so he's real important. And I think he's such an authority about this that what he says in this book about the expansion of the universe kind of becomes the established orthodox view of the story. And
something that I read many years ago, as far as Lemaitre goes, he actually got in touch with Einstein somehow, and Einstein read his theory, didn't think much of it at all. It was remarkably different from the Big Bang Theory. I mean, completely different. There wasn't like an initial singularity or explosion. It was sort of more like atoms, like this particles combine and just expand, sort of similar to, the way that organisms split, like microorganisms split. It was just outlandish. Though they took the idea and just totally adapted it when the Hubble observations came into play, and they sort of use that, but they don't go into Lemaitre's actual theory, though, which was remarkably different, too.
Yes, I talked about this, and I actually think his idea is closer to reality than the Big Bang Theory. And I talked about that yesterday, if you recall, where the Lemaitre universe starts off with what he calls the primeval atom. So you have a highly organized state, okay, this primeval atom, as he calls it, and it's, a very organized state, and then it disintegrates into to form the stars and galaxies. So it proceeds according to the law of entropy, that over time systems go from highly ordered states to disordered states, whereas the standard cosmology appears to go from a disordered state to an ordered state, which is contrary to the law of entropy. And so Roger Penrose argues that this is a problem for the standard cosmology. And I'm not going to go. He has a solution to that, which is his cyclical conformal cyclical cosmology, which I talked about. That's his solution to this issue of entropy. And he also has a solution to and I talked about this yesterday, that he has these different epochs of that one epoch joins into another epoch, and so that makes time and the universe infinite. Okay.
Another thing that bothers me is that we're are bringing into the conversation laws like the thermodynamic entropy thing, which basically appears to apply mainly to a special situation of gases and diffusion, of substances to equalize its distribution in a gas to all situations that which where the law of entropy obviously does not apply. For example, living things, it doesn't apply.
Well,
so why bring that in?
Well, because it makes your argument stronger if you're trying to argue against the Big Bang. I think that's what Roger Penrose is doing. I think I just clicked on the wrong thing here. Okay, so we got 10 seconds. I'm sorry, 10 minutes. Yeah, I got 9 minutes here. Okay.
Second law also applies to closed systems. So,
well, the universe is a closed system, isn't it?
Well, if you take it as infinite, which I do, it isn't really.
I guess you could argue that. I like the idea of, yeah, see, this is how they escape the, I talked about this, that how you escape the objections. So it looks like there's an objection, so, there's always a way to slither out of the objection. So you have laws of physics, but the laws of physics aren't universally applicable, because then you can put, it's only for bounded systems. So we escape that objection. You say
no. It is not closed system, guys. Our world is not a closed system. That's why we cannot apply our laws. It's not closed. We have all the time additional matter in our universe, in our world, in my world.
Well, that's
why, don't put this, for closed system, it's one story, the laws. The second one, even in our galaxy, we have additional one star every year. There are some galaxies with thousands and millions of new galaxies at this time, or stars. How to explain it? We have new order, we have new galaxies, we have a new stars. What about this loss? How to explain them?
well.
We don't have
You're getting ahead
the
of the
increase
story.
of our. I'm sorry. What do you want to tell?
Well, we're getting ahead of the story. That's, that's where they have a problem. But then they'll say, well, but that violates, the law of, matter can be neither created nor destroyed. So they have a theory that says we're going to create all matter and energy at the Big Bang, and then after that, no new matter or energy is created. Okay, and so they've sort of, chosen a law of physics that they like that supports their paradigm, and then that, so then they have to adhere to that theory. But then, when you say, well, is it possible that matter can be created, after the Big Bang? They reject that.
Exactly my point. It's exactly my point. Continuously creation of matter. Then everything is in order. No problem.
Well,
through what means does
entropy always going down, because we have some work done by universe, and we can down our order, disorder in our world.
How does the spontaneous
entropy
occur?
I'm sorry?
What is the cause of the spontaneous creation of matter? How does it work? Like, how did something come out of nothing?
Let's continue our talk today. How it works, it's another story. You are talking about the principles now. If there is no...
It's a valid question.
It's a good question. I told you in my model, the universe is responsible for creation of new matter in the world.
Have you explained how, though, like in your papers? Because I'd love to read it.
I cannot be a god to explain how universe creates it. I'm sorry, man. Maybe you can. I'm sorry?
Why accept the idea if you can't explain it?
Believe in Big Bang model.
Oh, I'm sorry. What did you say? I didn't hear what you said.
Any theory has some hypothesis. This is the main hypothesis of my model. That's it. And you can confirm the hypothesis only by results, experimental results that explained by new model, and then you can tell, okay, might be this hypothesis good. Even in mathematics, we have hypotheses, man. In physics, the same story. That's why you're asking about hypothesis. Believe in hypothesis by results you got based on this hypothesis. You cannot prove hypothesis itself. This is a logic of any science, man. I'm sorry.
You can disprove
I think
hypothesis.
Vladimir is using the word hypothesis, and perhaps a better word might be assumption.
Assumption, but in mathematics and in some other sciences, usually telling hypothesis. And what is the difference in your work? Assumption and hypothesis. Why do you like assumptions more?
Well, if it's something that can't be proven, that you basically start with an assumption. Hypothesis, usually in the scientific method, is usually a testable proposition.
No. It's it's a model. Model is you will check later. Assumptions, you want assumptions. Let's name it assumptions. I mean hypothesis. What I mean hypothesis. Yes. You started any science with hypothesis. Supposing two lines cross or they're parallel. You have one geometry, you have another geometry. It's assumption? No. It's a hypothesis. Axioms. In mathematics, it's axioms. It doesn't matter how you name it. but you have the very first assumptions based on some ideas. You cannot prove it. You must believe in it, and then you're checking how the world works based on these assumptions, your words.
Right.
Man,
so that their assumption or hypothesis is this Big Bang thing, all of the matter came into existence at some instant of time.
It is hypothesis, but it doesn't work. This is the point. Big Bang model right now in crisis. We know this for sure. That's why the original hypothesis, initial singularity, inflation, they don't work because we can see the result of this approach, of this hypothesis. Any model, electrical model, whatever, all of them we started with some hypothesis, axioms, you can name it assumptions, whatever, guys. It doesn't matter, but what is important? You can check it only by results, not you can explain how it works hypothesis, because then it's not a hypothesis, this is a theory, this is a result, this is, I don't know how to name it. But you cannot build any science without initial hypothesis. Even religion, it has some hypothesis. God exists, or there is another philosophy, but God doesn't exist. Can you check it? No.
Well,
That's why please follow the logic of any science. Hypothesis, results. Hypothesis, result. You can prove hypothesis if your result correlate with experimental results. This is the logic of any science.
We got a minute to go. So the mainstream hypothesis is that there's this Big Bang and everything appears out of nothing at some instant of time, t equals 0, and then from there they create a chain of reasoning that isn't really very clear because I'm not an expert in particle physics, but that gives them a certain amount of power over you as a skeptic because you don't know what gut is and you don't know all the details that go into the standard model of particle physics and all this other stuff, but still it sort of implies that energy and matter come out of nothing, which would appear to violate...
This is a hypothesis, matter out of nothing. Do you believe in it? I don't.
Well,
what is important, even the creation of matter, it's not my idea, guys, by the way. Dirac, he talked about this, some other guys. That's why it is not my idea. I use existent idea from 1937. Gravitational constant, not a constant. There is a creation of matter. Of course, it's hypothesis. But I can prove this hypothesis.
Now, this modern scientific method, so-called, seems to be that they make a couple of dubious assumptions, and then instead of being open to the possibility that they're wrong, they say, well, no, the experimental evidence have proved that we're right, and they introduce more doubtful assumptions, and they get this system, which I think all of us here think is absurd, but it's believed in by the majority of mainstream scientists.
I think you summed it up pretty clearly. That sums it up pretty well. The reason I brought up Eddington's book is Eddington comes across as basically talking the way you described. You know, we know what we're talking about, and the way he goes about rejecting alternative ideas, you know, it sounds really reasonable, but then you sort of wind up wondering, well, why? It sounds good when you read his book, but the more you think about it, the less questionable it becomes.
See, Eddington might even be a bit more dangerous because he's the soft cop. You know, he's explaining to you why this is the best system and why.
Right.
The hard cop is the more modern people who say, you don't understand this, you've no knowledge of it, and you're ignorant and you're not a professional. That's the hard cop, and you can easily sort of dismiss that. But the soft cop is very difficult to dismiss. It seems so reasonable.
Right, that's exactly right. That's why I brought up Eddington's book, because it seems reasonable. It seems so inevitably true. You read his book, and it's very persuasive. I mean, he talks to the average reader on the average reader's level. He doesn't talk down to you from, you know, a highfalutin scientist point of view, and it's he comes across very convincing. And so I think my thesis is by the you know, when this book comes out, okay, you know, and all the and that's become the orthodoxy. And so this orthodoxy of the expanding space is pretty well established. You know, after he writes his book, which basically is the late 30s, you know, it gets republished in paperback, I believe, in 1940. You know, and a very inexpensive paperback book that any layman, you know, can go and say, oh, I've heard about this expanding universe idea. What's he talking about? And you read his book, and it's very, you know, he explains everything very simply and clearly. And so you really can't think of any reason why it might not be true. It's very persuasive, actually. So anyway, I'm on the wrong page here. Okay, so I was thinking about this, and basically what they're saying is that there's an absolute time, an absolute universal time, and that it's kind of difficult to explain exactly how they reduce general relativity down to these line element equations, okay, and which is a metric equation, you know, and it's a differential equation that that combines distance and time according to the general relativity formula. And you scale factor R in the solution, and the parameter R becomes a function of time. So that's the scale factor. When you see these diagrams that they show of the universe expanding, then there are two-dimensional diagrams. The one, as time goes on, the universe is getting bigger, it's expanding, and what that is referring to is the scale factor, R, usually is written. And so if the space is expanding, this R is a kind of a mathematical dilation of space. Okay, and what is a dilation? I'll talk about that later. A mathematical dilation is an idealized conception of space inconsistent with quantization of space. So, you know, this is kind of where I sort of wonder how can you bring quantum theory into a theory that's, you know, based on general relativity, which doesn't have a quantized space. So I think they're still struggling with this. I don't think there's a real answer to this, but I think they're inconsistent, and so that would be contradictory according to what Jim says. Okay, dilation definition. A dilation is a transformation that changes the size of a geometrical figure but does not change its shape. The dilation math definition indicates that the shape of the figure will not be changed. Instead, the length of each individual side will be changed in a proportional manner. So if it's a dilation, then atoms ought to change their size as space is expanding, right? But that doesn't seem to be the assumption that they're using. So to me, this is kind of unclear. And of course,
is this that accepted of a theory? I've never heard of this.
you never heard of what do you mean?
Uh, Dilation in terms of something physically growing. I've heard of time.
Well, dilation is a mathematical concept. It's an idealization. Okay.
Well, does mathematical mean it only applies to mathematics and isn't true in reality, or is it an accurate mathematical description of the reality?
Well, now you're asking what is the function of science? Science takes mathematics and attempts to impose mathematics on the physical world, and if they appear to match up, then they say, "Oh, that's a good way of that's our theory, our mathematical theory." So, general relativity is a mathematical theory that supposedly realizes or is a description or a realization of what space is like. Okay, so it's a mathematical idealization that is supposedly representative of what nature is in reality. That's kind of a questionable. Does that make sense to you?
Yeah.
But this business of the atom not taking part in this dilation is quite anomalous. I mean, one might conceive of the nucleons as being massive particles, which they contain mass, and therefore, for some reason or other, they don't change. But most of an atom is empty space. So the empty space in an atom is different from the space at large. It doesn't expand, but all the other space expands. So in other words, it contracts in relation to the universe at large.
Yeah, you would think so. And the reason I'm bringing this up because this bothers me. I don't quite get it all. How is this all supposed to work?
Or it would seem if an object grows in size, that all of its constituent atoms would also have to grow to accommodate that.
Okay, I'm going to go get a book that has a picture in it, and I'll be back. Why don't you guys talk to yourselves?
Let me tell you my understanding of it. First of all, atoms, they don't change. Because all the electromagnetic theory, it's a constant. Gravitation is not constant, but electromagnetic, constant. Electron is electron all the time, from the beginning up to now. Atom is from the beginning the same, no difference, because electromagnetic force constant, always the same. That's why don't touch atoms. From the other side, atom is what it is? Quantum physics. Don't mix quantum physics with classical physics. That's why space of atom, it doesn't exist for us, classical objects. That's why even this, Planck's length, Planck's mass, and Planck's, space, it doesn't exist for us. It's so small that it's a quantum physics. Ask them. By the way, all your questions, ask them how they explain it. I cannot. I'm a classical physicist. That's it, simple like this. That's why, guys, don't mix it. Quantum physics put aside. Let's talk about classical physics. Because gravitation, it's a classical physics. Sorry. That's why, and don't touch atoms. Atoms is okay. They survive all this time. The same.
Well, I think the point here, I think you made a very good case for getting rid of the Big Bang idea right there, because Big Bang, in my opinion, is a combination of quantum physics with classical physics. Okay, because in order to have a Big Bang, you have to have all these quantum physics rules to govern the nature of particle physics, which is used to create matter out of nothing. So classical physics has nothing, they're attempting to put them together. That's kind of my point I'm making. And
yes.
Do they?
Gravitation, it's a bullshit from the beginning, you know. To combine quantum physics with classical physics, it's absolutely wrong. That's why don't mention Big Bang model, because they're trying to do it. It's absolutely wrong. It's against, you know, definitions. Classical physics, quantum physics. And what we can measure in classical physics, we can compare with experimental results. But quantum physics, it's a totally different story. We know nothing about it.
Vladimir, would you say there's anything questionable or even mistaken regarding quantum mechanics?
I'm not expert in quantum mechanics. Leave them, because quantum mechanics right now in crisis too. Believe me, I checked it, I know it, but I don't want even to touch it, because whatever they will decide to do with quantum physics is their business. It's not mine. I'm sorry. But what is important, there is a border between one and another one. And many times I told you, you have one quantum object, quantum physics. You have ensemble of quantum objects, it's classical physics. We are in business of ensembles. Sorry. Simple definition.
To
get back to the point,
the electrical charge and the electron considered classical physics, Vlad?
No, it's quantum physics. Classical physics, you know, we don't. By the way, in classical physics, we don't
accept
have
that
charge.
electrons exist.
You know, I accept.
I heard you talk about electrons and protons and plasma repeatedly, and now you're saying that quantization does not, you know, is.
No, you have no
I
logic.
think this
I'm
is
very
more a
sorry.
word game.
It doesn't. No, you're not right. I will tell you. We have air in our room. It consists of particles. But I don't know these particles. I know the statistics of these particles. I know ensemble of these particles. And I can measure the temperature and compare statistical results by Maxwell and what we have around. Do we know something about oxygen, nitrogen atoms? No. For classical physics, we don't need it. We don't need it. We have our ensemble, and we have a statistical ensemble of statistical analysis of these ensembles. That's it.
Yeah, well, I've heard
And the same story with quantum physics. The same story.
I've heard you talk about the periodic table. That we don't need, right? We don't need like plutonium and its decay that you discussed previously and so forth.
It does seem that quantum mechanics approaches particles way differently than classical physics or just ordinary physics.
Let's continue. Plutonium. We have some samples of plutonium. We found on the Mother Earth, on the surface, this plutonium, and nobody can explain why it exists with half-life 80 million years, and we have 4.6 billion years of our Earth planet. No explanation. But in any case, we don't have atom of plutonium. We have some mass of it. We are measuring some properties of the ensemble of atoms of plutonium. And I believe in it. I believe in plasma. But plasma, one more time, it is a classical object. We don't have one electron, one proton. It's atom. We have ensemble of electrons and ensemble of protons.
So you accept that there are electrons and protons?
Yes, there are electrons and protons, but we are measuring characteristics of their ensembles. Because plasma physics, it's ensemble. You can see the wavelengths in the plasma. Wavelengths, it's classical physics. Guys, all the time I want to try to explain all the time. Ensemble. I told you about this, this interference experiment. You have two slits. You are not touching this ensemble of photons. You can see this, some scattering, some lines on the screen. If you will try to measure where is the photon coming, through this slot or this slot, immediately you lost this interference pattern. Come on, how come? where you put only observation of each photon and immediately you destroy classical notion, wavelengths, there is no interference. This is a miracle. No. It is exactly the border between classical physics and quantum physics. Yes, I do believe in photons, but whenever you are trying to see photons, you lost your classical physics at all. There is no interference. And it's well-known experiment. Observation problem. There is such even problem. I solved it in a simple way. You're looking for one photon, you lost your between this ensemble of electrons, photons, whatever. And on the contrary, you're not touching it. They are going through these slots with interference pattern. Guys, always, all the time, I was trying to tell you this: don't go past this border between classical physics and quantum physics. Simple as that. Yes, I do believe in electron and proton, but I can measure only the characteristics of plasma, not one electron, one proton. No, ensemble of them. Yes, I believe in it. Not only believe, I introduced this intergalactic plasma and I measured the concentration of them and so on and so on. That's why, but plasma, not each electron and proton. The same story in our area. We don't talk about in statistical analysis about each atom, each molecule, and so on. We're talking about ensemble and statistical movement of them. What is the average kinetic energy, temperature? Simple like this.
I think the issue here is, and that was the issue that I was trying to talk about yesterday, is the Big Bang is a paradigm that puts together quantum physics and classical physics and smashes them together and then expects you to believe that what they're saying is correct.
Absolutely wrong. That's why don't mention Big Bang model. It's not only obsolete, it's obsolete already. There is no logic in this theory at all. And they are trying to continue this quantum gravitation bullshit. It's a mathematical tricks. That's it.
Right.
I think we may have reached a little impasse with regard to the proposition that atoms do not partake in the expansion of space, which nevertheless exists everywhere else. I mean, a few questions present themselves. One is, do molecules also not expand? And then, of course, one perceives of the universe at large being empty space, let's say a vacuum, and they have no problem in saying, well, that expands. So if you have a concentrated gas like hydrogen or helium or something, maybe that doesn't expand, or does it expand to the same extent? If you have a liquid, perhaps that doesn't expand. If you have a solid, perhaps that doesn't expand, because that's basically compacted atoms. So there are a number of questions which I think perhaps the mainstream haven't really been asked. Is expansion only really applicable to vacuums?
I think one point that's related is that I think a lot of Big Bang theorists suggest that that space-time expands with all physical phenomena, and that it stretches and warps, that space is somehow something physical. And they seem to don't admit that surrounding this obviously finite universe, there's empty space there. That they seem to deny that that's there, which that would seem real space. And it would also seem that if the universe is expanding somehow, that it's expanding in empty space. That space doesn't warp and stretch and such. Just thought.
I'm not sure if you would get a unified answer from them, actually. I think some of them might say that atoms do expand also.
What you could do here is do it in the form of a dilemma.
No.
You could try both and try to deduce an absurdity for both. Because I'm not sure which way. I mean, both sound about equally plausible to me, and if there's an absurdity both ways, then you can refute it.
Let me tell you the difference, guys. There is electromagnetism and there is a gravitomagnetism. Electromagnetism, all the parameters constant. If you're talking about the object that managed by electromagnetic forces, electromagnetic behavior, all of them constant. Constant. That's why if you have your atom, it's a constant because we calculate the properties of atom based on electromagnetic theory. Electromagnetic. That's why whatever we're calculating on charge, on electromagnetic equations, it's all of this constant all the time. Gravity-mechanism is different from electromagnetism, but variable parameters of it. Gravity-magnetism has parameters that they change with time. Whatever we manage with gravity, it's changing. First of all, stop talking about expansion, because there is no expansion at all. It's a wrong definition. There is stretching. Expansion, show me where it came from. What is the initial thing of where it is?
My
That's
point
it.
is,
Expansion, it's a wrong definition. Don't name it. There is no
well,
initial
the
singularity.
problem
Show me
is,
where it is.
the problem is that my view of it is that's they've adopted this idea, okay, the expansion of space. It's really basically described by Eddington in his book, and his book makes this it's because Eddington wrote this book and all these people read it and believe it, that means it's scientific fact now. So that's it's become very difficult to get rid of it. That's and then the next step is mashing. Gamov and his little students come along and they go, oh, we can apply quantum mechanics to cosmology and then bring quantum mechanics into cosmology. And so then they, I talked about this before, and I don't, they're so, how should I put this? Enamored, that's the word. They're enamored with this whole idea that they can explain the universe by taking quantum mechanics and combining it with general relativity, and they've got all the answers.
The problem is that conventional quantum mechanics is only partial and it's incomplete. And so that is destined to fail, that combination of the two. You're taking some, both involve the assumption that space and time are continuous variables. And so both are, in fact, incomplete and not applicable.
Well, okay, so what is that? I'm kind of the opinion that trying to, by bringing in general relativity, I'm not 100% convinced that relativity, well, I personally don't believe in special relativity. And there's too many flaws in special relativity. So bringing general relativity in and I could see, this is kind of how I view it. They're enamored with Einstein, okay. Eddington does this experiment, with the bending of light. This is a primary prediction of general relativity. General relativity is proved. Special relativity is right. That's become, this big pillar of physics. It's, they get a big propaganda campaign going. Meanwhile, at the same time, quantum mechanics is being developed. But it's not really clear to me that general relativity is correct. And because I don't believe in special relativity, so I have a problem with that. And it just, to me, it's all just a mess. They're enamored with general relativity, and cosmology looks to them to be the ultimate proof of the correctness of general relativity. So the whole
How is that? I thought there was missing mass.
Well, exactly. Yeah, right.
General relativity and universal gravitation both fail.
No, once they brought in dark matter and fudge factors to save the theories from being disproved. You see, they're constantly bringing in new ideas to save the basic paradigm that they.
But there's no established proof for dark matter, and so basically the conclusion is that general relativity as well as universal gravitation of Newton both fail.
Right, they're not willing to
agree with the
that.
facts.
They're not
Well,
willing to.
universal gravitation may not fail, one could argue, Jim.
How?
I mean, they find that based on certain assumptions, they're not getting the right values. But one of those assumptions, things like looking at distant galaxies and conceiving them to be, the matter that we actually see, conceiving that to be matter at a particular juncture rather than a composite image. So something is wrong. Something is rotten in the state of Denmark, and I would concur that general relativity seems to fall at the first hurdle. But I'd be more cautious about whether modifications to Newton's theory are required. Perhaps so, but I don't think that's as obvious.
Well, as R goes to zero, then if you're a Newtonian in that, you're positing that you have infinite mass.
Yeah, I think it was James Aratun who addressed that point to you. I don't know satisfactorily, but he said no. Those equations, the Newtonian equation and the Coulomb equation and so on, they blow up, so they're not valid for R equals 0.
Of course they are not valid, no doubts about it.
Yeah, right.
Let's come to expansion, guys, because our main idea today is expansion. I have only simple questions. Please try to answer it. First of all, where is the beginning of this expansion? I mean, where is initial singularity? And the second point, what is the mechanism of expansion? What is the mechanism? Because you cannot explore and then how to continue this without this first initial explosion. Two questions about expansion. Where it started and what is the mechanism of this expansion?
I mean, the way it seems to me is that the initial explosion is the impetus that keeps everything flying away. It's sort of, in effect, an escape velocity to where there's nothing there to prevent it from slowing down, so it continues. That's the way they say.
By the way, when they report that Einstein introduced the cosmological constant to stop the universe expanding in his model and to keep it static, perhaps the reality is the opposite. The model, the gravitational model, would appear to indicate that everything would collapse. And in order to stop that happening, he introduced a cosmological constant. So I'm not sure, I'm just checking now, but it seems to me that it's incorrect, that the cosmological constant was introduced by Einstein, whether correctly or incorrectly, to stop the universe collapsing, not expanding.
Well,
I think you're probably correct.
Einstein did suggest in his cosmological considerations of general relativity that he suggested that the universe is either expanding or contracting to account for why there isn't just a gigantic collapse caused by gravity of everything in the universe collapsing upon each other. But his idea of expansion was vastly different than the Big Bang idea of expansion.
Some comment. Einstein, he worked with static universe, static. And mathematicians immediately saw that his equations unstable. There is no static equation. There is no static universe. He introduced this parameter, this concept, I don't know how to name it, lambda, it doesn't matter, to stop the instability. These equations, it's so bad that they're unstable even. That's why he trying to save his equation from mathematical point of view to introduce this concept. instability, and nobody talking. It should be this one or that one, it doesn't matter, but it's unstable. And he put it, and then when somebody, Hubble, he showed him that expansion exists, oh my goodness, it was my main mistake, because he tried to save static universe, and it's expanded, then you don't need this parameter. And suddenly in 50 years after that, somebody introduced one more time for some other reasons. Now we are talking about lambda. You see how it's, look, even from mathematical point of view, these equations doesn't work, man, doesn't work.
There was also the popular idea before dark energy entered the equation that, you know, the possibility of a big crunch where everything would slow down, stop expanding, and even retract into somehow a pinpoint again, and then spontaneously explode again.
Let me ask you an additional question. If our universe, it's, infinite, what does it mean, expansion of infinity? I cannot understand it. It's infinite, practically it's infinite. The name, the definition expansion with infinite universe. What is expansion? Expands what?
I would say that if the universe is finite and that it continues to expand, no matter how long it expands, it can never reach infinity.
The universe or world in my model is finite. It's exactly my point. In my model, then for finite it's the universe, you can tell not expansion, stretching. Many times I told there is a difference. And by the way, Harry, thank you so much. You refer to some guy who told about stretching of the universe, not expansion. It's absolutely right. Expansion, absolutely wrong definition. If we cannot use this word. We cannot. But stretching, yes, if it's your universe finite, then you can tell, oh, yeah, there is something to increase, volume, surface, whatever. But it should be finite.
Would you say the universe increases in some size somehow?
The world, yes. The world, yes. There is a stretching of it. Stretching. And what is important? Atoms, they're stable, but distance between superclusters increases because all the galaxies, like in our solar system, they belong to some big structure named superclusters. They are moving around superclusters like our planets moving around the sun. But centers of these superclusters, they are moving apart. This is a simple explanation of stretching. Don't talk. By the way, in electromagnetic phenomena, we never use gravitation. And on the contrary, in gravitation, we don't need to use electromagnetic. It's two different sciences even. That's why we have our superclusters. They are moving apart. They can see there is a distance between them. Simple like that. But inside of these superclusters, the main player is gravitation. Gravitation. That's it. They are moving like our planets around the sun. They are moving around the center of superclusters. Do you know that our galaxy belongs to Laniakea? 10 to the power 15 galaxies belong to this supercluster. They are moving according to gravitation around the center of it. There is some special name, I will not tell you, it doesn't matter. And all these big clumps, they are moving apart. So this is the story. And all these redshifts, it's a bullshit, because let me tell you, in our solar system, one planet going out from Earth, another one going up to us. Let me ask you the question. We have a redshift and blowshift in the same system, solar system. And the same story with superclusters. You have your center, like our sun, and you have all the galaxies around. Some of them moving to us, some of them going out. It belongs to the same supercluster. And you can see blue shifted. tight light, forget about it, because there are blue shifted galaxies. They have more energy in photons coming to us. Why? Because this galaxy we are particularly measuring our distance to them, it's moving to us, like Andromeda galaxy moving to us. You know, big parts of them, they're moving up and down, it's up to them. But even Andromeda belongs to the same Laniakea supercluster. It's another planet around the center of supercluster. And that's it. That's why Enela take a look on our solar system. The same story with galaxies. They belong to the center like our sun, and they're moving against each other in different way. Blue shifted, red shifted. It's the characteristics of internal movement of superclusters.
Well, it sounds to me like you're
for my
talking.
emotions, because I'm tired of Big Bang and all this bullshit. Expansion. There is no expansion. About atom increase, no. Atom, it belongs to electromagnetic phenomena. If you introduce, by the way, in Maxwell equations, there is no charge. There is energy density, charge density. There is no charge. Charge belongs to quantum physics. We introduce electron with this charge, okay, quantum physics. In Maxwell equation, there is none. Nobody knows the real value of the electromagnetic theory in Maxwell equations. We are trying to put inside of Maxwell equations electrons, protons, all this stuff. No, it's a quantum. Leave them to take care about. Well, guys, sorry for my emotions as usually, because I'm tired about this Big Bang model, about this logic. There is no logic. There is no even standard logic for common people. How come?
Well, I think the issue is there's more than just the Big Bang Theory. I think that the issue is that, science in general lacks logical coherence, although they present it as if it does. But I think there's a lot of logical incoherence. You mentioned electromagnetic theory. I mean, there's a lot of logical incoherence in electromagnetic theory in Maxwell's work, and the way they teach it is not really very convincing.
I agree, but what is important for me in electromagnetic theories, parameters constant. There is, it doesn't matter. There is wave resistance and all this stuff, they are constant. But what is important, always we are talking about the Maxwell equations in vacuum, because it's much more complicated if you will take into account medium.
Way. It's mind-boggling to think that way.
Well, go ahead and respond to Jerry. I'm sorry.
I think the real issue in my mind has to do with once you've adopted the Big Bang theory or an ideology. I think it's more of an ideology, really. Once you've adopted that ideology and you've adopted the ideology of the laws of physics, okay, so and what Vladimir, I think, has pointed out pretty clearly is that there are different versions of ideology. So, for instance, if you're a quantum physicist, you have an ideology of quantum physics. If you're a classical physicist, you have an ideology of classical physics. And then problems arise when you try to combine these ideologies together to explain systems that aren't explained in one or the other ways of thinking. Okay. And what they've done is they've created a kind of a mongrel beast of combinations of these different ideologies. So you have an ideology of classical physics, an ideology of quantum physics, and trying to combine these ideologies is not really working out. I think that's the conclusion we come to. And I doubt that they're going to come to that conclusion. Cosmology is kind of not a very good mongrel beast in terms of something that makes sense. But because of the observational astronomy in the past was not really able to refute this cosmological ideology, and because they're, they couldn't even pin down what the Hubble constant was, to within this wide range, 50 to 120 it could be. So they couldn't really, make any measurements or prove anything. But now they're getting to the point where they think they can. But we still have the Hubble tension, the disagreement between different measurements of making measurements, and the JWST is supposedly showing that cosmology is in crisis, and whatever that means, because what they're seeing doesn't really agree with what they want to see. Right?
What do you mean when you say that the conservation of energy only applies to closed systems?
Well, that's kind of their
It's a law of physics.
Right.
Let me tell you, they didn't answer even why we can use laws in the whole universe, what we have on Mother Earth. Why? Answer from Big Bang model. Why?
One can look at instances where energy is conserved and still have an idea that the universe is infinite in size, or unknowable in terms of its size.
Well, I'm not sure what you're saying. I'm
Yes.
just the idea. What I'm saying is, you have a system of thought that has. When you say something's a law of physics, then you've established a full philosophy of belief based on some principles that you've accepted are true, like religion, and then you have to believe that they're true, and they have to always be true, because that's what it means to be a law of physics. But we don't know that these laws of physics are always true. They just tell us that they are. And so in the example of the entropy law and the law of violation of thermodynamics law, energy can neither be created nor destroyed. I mean, that's a law of physics. Okay. But it turns out that in the Big Bang, that theory is disregarded. That law is disregarded. So, and then they have to give excuses why that's okay to do that. But
Well, maybe it's time for us to start constructing a theory that does make sense.
well, that's the point. That's what Vadimir's been trying to say.
Yes. Let me tell you about my
I've
understanding
been
of the
saying that
laws.
as well.
One sec. Let me finish my own question. First of all, they don't answer this question. Why we can use the same physical laws in the whole universe? I will tell you why in my model. Because in my model, 2/3, 66% of matter in the medium of the world. Medium is homogeneous, isotropic in all the universe. All the galaxies, like particles, flying inside of this medium. And all the physical laws depends on the characteristics of the medium. Our galaxies, stars, and everything, it's like particles inside a huge medium, like a liquid, like an air in our rooms, and so on and so on. That's why I proved the main point that laws of physics stable, because we have all the medium homogeneous. It's a medium of the universe, and all the laws depends on the medium only. Not on stars, not on galaxies, no, on the medium. You see what I mean? I confirmed even this principle. We can use physical laws everywhere. Sorry.
Okay, I understand that part.
Come in? Where do all of the anisotropies come in?
Anisotropy,
Well,
there is no, in the medium, there is no anisotropy. It's a homogeneous, like liquid, like air inside of this room. Anisotropical macro objects, these, clusters, superclusters, galaxies, yes, anisotropic, but laws of them, it's a different story. Laws of physics, we apply to these macro objects, based on the medium of the world. Medium, homogeneous, isotropic, the same. Where this all the same. It's absolute. It's absolute of the model of our world. You see, it's a very important advantage of my model to show, guys, we must use the same laws because laws depend on the medium. And what is in Big Bang? Vacuum. There is no medium. Guys, how you can talk about this stability of our laws?
Well, that's kind of goes.
I'm tired to hear this bullshit from Big Bang model. I'm tired, man. No, whatever you're touching, everything wrong. Everything wrong.
I can't disagree with that, and then I understand that point. I like the idea that what you're saying but that's kind of similar to Mach's principle. I think what you're saying is similar to Mach's principle, and they kind of want to invoke Mach's principle when it's convenient for them to bring Mach's principle in. But it doesn't seem to me that it's very convincing how they do it. They are using now this idea of the Higgs field, I think.
Eddington wrote another book, a larger book called The Nature of the Physical World. I don't know if you're aware of that. But I just remember one little anecdote. He gave the lectures actually in Edinburgh, and he was asked a question. You must find the journey up from London to Edinburgh very tiring. You're stuck in a box and you're jostled around the way for over 3 hours, and then you get here and so on. But how can that be if you're in a stationary object and the whole universe is moving around you? You wouldn't feel any jostling. Well, he invoked Mach's principle basically to try to explain that.
Right. That's, I think, what Vladimir is saying, that the local physical laws are derived from the medium, which implies, in my mind, an absoluteness of time and space.
Yes.
Time and space are absolute, and that's, and general relativity or relativity doesn't say that. There's no absoluteness anywhere, and that. One of my points that I was really trying to get at here is that cosmology assumes time and space are absolute, but based on a theory that says they're not absolute. That's where I don't quite get what's going on there. So obviously we have to get rid of the relative and create some absolutes. The universe sort of forces us to believe in absolutes.
It's like getting some recruits for binary mechanics. That's great. There's two. Vlad and Harry, well, welcome aboard.
Well, I don't, in a way, science wants to...
We're going to throw a party for you. You are welcome.
Well, I see this as a problem in science because they want to say things aren't absolute, but then they kind of have to fall back on some kind of absoluteness as a concept in order to get anywhere. And so there's this tension between the absolute and the relative, and they haven't really basically come up with any real way of resolving that tension, that duality that exists there. They try to choose one or the other.
It seems that they seem to think that the absolute time, at least, exists only within a given frame, such as that time only isn't absolute when there's velocity of relative objects or gravity, different locations with one higher gravitational field over one, say, in outer space. I mean, those seem the only two examples I can think of.
Yeah, well, time's kind of, to me, when I see these cosmology diagrams and they show time on the diagram, that tells me that they're talking about something that's absolute. They think there's some absolute something called time. What is that? That's never, I have no idea what that means. That's another puzzle.
Let me tell you a few words about time, guys. Let me tell you a few words. They have a linear time. They are using like a solar time, you know, and then they have extrapolation to t equals 0. Then initial singularity and all this stuff. In my world, I am not talking in reality. All the parameters, they are not proportional to time. They're inversely proportional of time. Inversely. And if you will take the cosmological time, inversely proportional all the parameters, then you will see there is no t0 because at t0 it will be infinity value of any parameter. That's why in my model there is no t0 at all. There is some minimum time, and I put 10 to the minus 18 seconds, from where you started your universe. You see, even the value of t0, there is no, because time cosmological and all the parameters, they don't change proportionally to time. Inversely proportional. Hubble parameter inversely, gravitational parameter inversely, and density of the intergalactic plasma, and so on and so on. Even microwave background radiation, inversely proportional. Simple like this. Totally different the idea of time. Many times I told, there is a solar time, we used to it at school, but you cannot use this time because solar system 4.6 billion years. How you can produce the same time for the whole universe 13.8 billion years? How? That's why variation of main parameters, Hubble, gravitation, proportionally to inverse of time shows there is no t0 problem at all. There is no such a point. There is no initial singularity.
Well, I agree. I don't really quite. That's kind of a fantasy that I'm not sure. I guess that comes out of the Friedman models. That you solve a differential equation. When you solve a differential equation, you start at t equals 0. I mean,
yes.
What happens?
But Friedman equations, they used even perfect fluid. They put for vacuum such definitions like pressure, that's density,
Right.
mass density, and all this stuff. Guys, do you have vacuum or you have your perfect liquid? No. Tell me one. You are talking about the hypothesis, guys. Many times I told you. So many logical contradictions in a Big Bang model. There is a vacuum or there is a perfect medium. Friedman equation, they use them. It's all exactly, with perfect fluid. It means there is no vacuum. How you can use vacuum? This, I don't know. And it's a prevailing theory right now, filled with all the contradictions. That in Friedman equation, everybody trying, but there is perfect fluid. Well, tell me, what does it mean? It's a ether or what? 1905, you cut this ether. Right now in Friedman 22, you put one more, this ether. Come on, guys.
Yeah, that's
it's
another.
exactly my point about the hypothesis. Put one hypothesis and then have a logic going from this hypothesis. If you have a contradiction between hypotheses, forget it. It's not a theory at all. Hypothesis must be stable. You put it like a stone, and I will start from this hypothesis, then build all the building based on these stones, and don't go away from it. This is any science must go only this way.
Well, okay, so you just basically explained why, as soon as these ad hoc things come in, as soon as I've got an ad hoc dark energy or whatever, that theory goes out the window. Yeah, I don't think that's how they do things, though. I think they do things by consensus as to, they go to a conference and they sit around and then they decide this is what we think is the right answer. And then once that's been decided, they all go home and try to make everybody else believe in that agreement that they agreed at a conference. I think that's how it works. And the editors of the journals, if somebody tries to publish a paper that doesn't agree with the consensus, the supposed consensus, they don't let him publish it until he changes the paper so that it doesn't violate the consensus, but
but that has changed now because anybody can publish on the internet these days. There's WordPress, there's Blogspot, the Blogger, there's many other opportunities. There's angelfire.com where you can, overnight create your own website and publish anything you want to publish. So the cabal, if you will, has really lost their power, and the folks here might become more social activists in this media, which is available, by calling out some of the leaders of the cabal and demanding that they publicly release information. So I can elaborate more on that point if you want, but it's an idea that the technology available to us now makes our voice much stronger, I believe.
Well, we see this happening in politics, where the mainstream media here in the United States, the CBS, ABC, NBC, those big, powerful newspaper organizations have been controlling things for so long. They're desperately trying to hold on. Although their credibility is, the polls show that their credibility isn't really as good as it used to be. But I think in the scientific arena, there's still, a large public perception that what scientists say is true, although Fauci did poke a big, gigantic hole in that with his pronouncements on COVID. But I think as far as topics like cosmology is concerned, I think people are still believing in Einstein. They're still believing in Stephen Hawking, who's this brilliant guy who's celebrated. Everybody thinks he's great and wonderful, that sort of thing. To me, it's ironic that Roger Penrose is not following the orthodoxy, but I don't know that there are many more like him out there. And I know I mentioned this guy Disney yesterday. He seems to have lost his job. I don't know whether that's really true or not, but I read that. And, some of the other critics don't seem to get much traction because, it's a religion, basically. You can't
how many people here have X.com accounts?
Well, I don't know, but
raise your hands.
Nobody.
Let me give you
I'm
another
the only one.
Yes, probably.
That is the free speech platform in the world today. Okay, and so
I know all this.
I could hardly believe. In other words, this group here, you ought to get to your accounts and start calling out. Find out who the director of CERN is. Find out who the director of Fermilab is, and the other U.S. national labs. Call them out. Find out, who the principal investigators are, which is a small handful of people, which account for multi-millions of dollars of research grants at Fermilab, and call out these individuals. A lot of them will have X accounts. You can call them out.
Right, but I don't really see how that goes anywhere.
How does it go anywhere? Well, eventually, one or all of us here will be featured guests on various interview programs.
Assuming you don't get blocked.
Well,
but in general, we're not about nature. Now maybe this is a weakness.
Thinking is not going to help.
We're talking among ourselves here on a Sunday, and that's great. Somebody like David the Hillster maybe is a bit more like that. He said, "Oh yes, let's show the message and let's get something which is sexy and put it out there and so on." But I mean, for my part, it's probably a failing. I'm not missionary. I don't want to convince anybody. If somebody wants to listen, I'll talk to him and I'll say, okay, let's go into the deal. But I'm not a missionary by nature. Now, maybe that needs to change, if you want to spread the word. But that is the problem with us scientific dissidents, I think.
Well, David used to speak of how he would go to Facebook, the main Einstein page, and he would debate ideas, and people would attack him and such, of course. But he thought that since, there are like millions of people who subscribe to that account, so he's reaching a lot of people. Even if only a few of them are tuned in, he's reaching a lot of people, possibly changing their minds about things.
Well, I tell you what, go to @BINMECHLAB @BindMechLab on Twitter and look at the posts. Every time I post with a reference to one of my papers,
Jim, send this reference to all of us. Please send by letter, because always we're doing mistake when you're talking about some letters. Please send this reference to all of us, and then we will see by ourselves, because I don't want to do a mistake by your voice. The second very important point.
But if you go to my Twitter account and look at the posts, this is a fact. Every time I make a post, and you can look at what they are, and reference a paper, and then go to Google Analytics 24 or 48 hours later for my Journal of Binary Mechanics, which is, on blogspot.com. And I find that those papers have been viewed 7, 8, 9, 10, 20 times. So that people are looking at the post, they're following up by reading the technical content in the papers that I've published. Vlad talks about all the 200 or whatever papers that he's published. All you need to do is to promote your work and get the word out. Because, we can sit here, as Ian said, and just talk to ourselves. But if you want to get the word out, and that's something I've been trying as an experiment with regard to my work in binary mechanics. So I invite you, that's
reference, and that's it. You are talking about the same many times. Please send us a reference, this link, and that's it. I will strongly recommend them. I'm an old-fashioned guy. I do like published papers. During 10 years, I published 38 articles in the Journal of High Energy Physics, Gravitation, and Cosmology. The chair of this journal is Professor Gordon. He is very flexible. He can publish any alternative publication, alternative cosmology theory. Please, you can send him, referring to me, that I referred you to send this letter to your paper, whatever, for publishing. And it's a referral journal. There are some guys who checking, he's doing some mistakes, I've done mistakes, they correct it. Always I'm telling, thank you so much for your corrections, for your questions, for your important influence on my paper, and so on and so on. That's why there are two options: to go to the Google, to some other pages or sites, whatever. And there are old-fashioned journals, and the name of this journal, 10 years already, Journal of High Energy Physics, Gravitation, and Cosmology. This is the right name of this journal. Whatever you have in your mind, send it, and see the referred already this paper, what are the questions, what they are doing, and so on. And there are some professors inside of this journal. It's not some students. It's professional guys.
Okay, if you click on
so
chat,
many papers in gravitation and cosmology. He's the expert in this business. And he published 38 papers, my own papers. That's why I strongly recommend you to go to him and publish whatever you have in your mind.
Well, I have my own journal. If you click on chat right now, at the bottom of your screen, click on chat. I put the Twitter link @BindMacLab in the chat for everyone to see. Yes, it's on X.com, which is the new version of Twitter. Okay, so if you click on chat, you'll see the link. Now, this journal that Vlad just mentioned reminds me of the so-called archive.org. You all familiar with archive.org, where hundreds of people publish papers? I call it the graveyard, where nobody goes and nobody reads them. Okay? For the journal that Vlad mentioned, do you have any feedback at all as to how many people actually read your papers? Probably not. So, if you make your own journal, you'll have that information. So, to summarize, the important fact for the kind of social activism that I'm experimenting with is that every post I make on X that references one of my papers, turns out that within hours after that, or 1 or 2, 3 days, you'll see that the viewership of that particular paper goes way up. And that can be determined from the Google Analytics for the blogspot.com site, where the Journal of Binary Mechanics resides. So that's my point. I'm a little bit surprised that nobody here, except me, has a Twitter account or an X.com account, as it's now called. And
Care really, Jim.
I never sign up.
I don't care. It doesn't interest me.
I mean, I think there is a lot to be accomplished through conversing with people. Just it doesn't have to be extensive. It may seem a very daunting task for a lot of people to read a complete paper. Though, if it's a conversation where you just quickly express your views that make sense and then refer them to your papers, you might get more traction. Possibly.
For example, if someone were to post on X.com an interesting, enticing statement about some scientific subject related to a Saturday CNPS presentation and give the link for that presentation, you would then have interested
Well, I suggest that you do that. Why don't you do that?
Video.
What is the result of your theory and your papers? Let me tell you guys, my journal, 10 years experience. I have over 25,000 downloading and over 80,000 opened my papers. How many references you have in your site? Tell me. What is the popularity of it? How many people they concerned about your theory and supported your theory?
I guess it's the process of building it up.
50,000 page views. But if your theory has received so many downloads, as you say, then the question becomes...
It's an experimental result. I can show you. It's experimental result for 10 years. I collected this references and...
You don't have to prove it. I accept your word.
We'll probably always be in a minority just talking among ourselves and writing papers in the academic journals. If we had unlimited funds and we got PR experts, I think you could change the world and you could have our system accepted. This is what has happened in the last generation with regard to things that are accepted nowadays, which would have been abhorrent a generation ago. I mean, and everybody is on top of it, like that there are many genders or, whatever you want to talk about, woke or whatever. 25 years ago, that would have been considered nonsense.
Yes, but those things are backed by lots and lots of money and funding that comes out of the political parties.
And I don't know if it would be worth the candle. I mean, things are accepted just because there's money behind it, or there's
because there's money behind it. Yes, money's behind it. Government support.
If it ever became accepted that the Big Bang was a lot of nonsense and that we were completely misled, you'd have the same thing. You'd have the careerists coming in accepting that and say, "Oh, we really always had doubts about it," and they wouldn't give credit to people who had questioned it on a theoretical basis. It would be the same PR people wanting to get information, and even these populist scientists who are on the media and are convincing the people. They'd be still in the limelight.
Well, I know that I didn't go after this guy Lincoln, the guy that does the videos for what's that lab Lincoln, I don't know what his name, Lincoln or something. He does these videos on YouTube about science, and so I sent him questions about his videos, which kind of is what Jim was suggesting. I said, well, I challenged him to explain how his videos were contradictory and didn't make sense. I never got an answer. I just got students writing me back saying that what he said was absolutely correct, and that I was wrong. And so what these people are going to do is they're just going to have an assistant write back and say you're wrong. The director told me that you're wrong.
Ivan, I want to continue your talk. Guys, one sec. It's very important. Dissidents over 20 years ago were much more active than we are right now. 3,000 of people of our society, no activity at all. They arranged 2 conferences. They had the publication. They write on the whole world from these conferences. At least there was some publicity for them. You see what I mean? Why our society cannot arrange conferences? And
They do. They have in the past. There's proceedings and that sort of thing. Yes, it's been done in the past. I don't know what they have scheduled for anytime soon. I don't think there's anything scheduled this year. I think it has to do with David DeHilster being overwhelmed. I think I'm not sure what's going on there. I went to a conference a couple of years ago, and there are regularly scheduled conferences, but I don't know that this is really the issue here. I think the issue here is why are people believing something that doesn't make much sense? Why are professional scientists believing something that doesn't really make much sense? That's kind of the question. And from what I'm hearing, they don't actually believe it, but they give it lip service. So when privately, when one professor talks to another professor, do you believe in this Big Bang thing? They go, oh, I don't really think it's true. I think it's a lot of cockabaloney. But they're not going to write a paper saying so.
There's money behind it. That's it, simple like this. But if you have open mind conference, you can tell whatever you want without any risk to lose money. Because we don't have money. I don't have money. I'm ready to talk to all the world without money.
I know that just on the, I for years used to write letters to senators and congressmen, about, you're supposed to, they say you write letters to your senators and congressmen, and all I'd get back would be form letters that barely had any connection to what I had written about when I wrote the letter. And so I don't know what they do with these letters when they get these letters. They throw them in a trash can someplace, or they take your name down. I think what they do is they take your name down and send you a form letter back that says thank you for your opinion, but my opinion is this. Okay. So when you engage in conversations like on Twitter, all you do is give them an opportunity for them to say you're wrong and I'm right. That's why but Jim may be doing it a little differently. I don't know. I do know that 20 years ago, the General Science Journal was supposed to be a really good place to publish papers if you were a dissident scientist. And I've had papers on there for 20 years, and it doesn't seem like there's been any interest or result from that. So I can't really... I'm not sure having people read your papers really translates into anything other than people read your papers.
crying. Conferences. We need conference.
Well, you need to, yeah. Okay. Well, this is a little bit beyond the topic that I wanted to talk about. We're going to get off of here. It's time to cut off. It's going to cut off. I think I think the opinion is, my view is that as you say, Radomir, there's not a logical consistency to science. And I think the illogical aspects of science is basically